So we are talking about the periodic table in this chapter, and so on Friday, you guys watched a video over kind of the history and how the startup of the periodic table came about. So these are the key names that we usually associate with the periodic table, and the father of the organization that you really heard a lot about in the video was Mendeleev, okay? And so the big thing to remember about him is that he organized it by atomic mass and properties, okay? And so I think that if you didn't watch the video, make sure you go back to Friday and watch that video. Moseley is the one who reorganized it now by the number of protons and saw more properties lining up, and therefore that is what we use to this day. So make sure you're familiar with at least those two names. So both of the arrangements on the periodic table had this idea of groups and periods. So remember, for our vocab words that we had in the last chapter, groups are the vertical columns that you'll see on your periodic table, and periods are the horizontal rows that you'll see across your periodic table. First, we're going to talk about those groups, or the vertical columns. They're also called families because they share similar properties. These similar properties have to do with something called the valence electrons. So valence just means that it's on the outside. So if you remember our Bohr model that we started the year with, we had to put the number of valence electrons on that outer ring, meaning those are the electrons that are going to be taken away or added to in order to give the different chemical properties that you'll see for the rest of the year. No matter what, though, the identity is still coming from your number of protons. That is your atomic number. So our groups basically determine what types of things are on the periodic table. So we've already learned that your metals take up the left-hand side of your periodic table for the most part, and your nonmetals are going to be more on the right side, and then you have your little staircase of metalloids right here. So as you saw also in your periodic table scavenger hunt, our first group, those guys are called alkali metals. And then our group 2 are called alkaline earth metals. Our middle portion, so these through underneath your staircase, those are called your transition metals. And then once we get to group 13 through 17, you're naming them by who's on the top. So this will be the boron family. So boron family, carbon family, nitrogen family, oxygen family. And then we get, for 17, we call these guys the halogens. And finally, we end with our noble gases, who are in group 18. So the other thing that keeps these guys similar down a group is going to be the number of valence electrons. So everyone in group 1, or my alkali metals, has 1 valence electron. Everyone in group 2, alkaline earth metals, has 2 valence electrons. Then we don't really talk about the valence electrons here because they can have multiple valence electrons, so we're not going to worry about that right now. But everyone in group 13, so another part of our main group elements, they all have 3 valence electrons. So what you're going to get in the habit of doing when you're looking at group 13 through 17 is you can't have more than 8 valence electrons. So what we're going to do, the easiest way to remember your valence electrons, is you're going to cross out the 1. So we have 3 valence electrons for group 13. We have 4 valence electrons for group 14. We have 5 valence electrons for group 15, 6 for group 16, 7 for all my halogens, and then 8 for all my noble gases. So remember, periods go across, groups go down. We have different types of elements throughout the periodic table that are separated into the 3 main groups, but then they each have their own name of vertical columns. And those vertical columns also guarantee that everything in that column is going to have the same number of valence electrons, okay? It will be important to us when we go to learn about things like electronegativity and ionization energy to understand the concept that atoms are going to tend to lose, gain, or share electrons in order to get an electron configuration like a noble gas, meaning 8 electrons in the outer shell, also known as an octet. The horizontal rows on the periodic table are also just as important. Remember, the horizontal rows are called periods. Periods are showing the number of energy levels. There are 7 periods on the table, on the periodic table, that can be seen on the left-hand side over here, okay? And these 2 lower levels you can see get inserted in period 6 and period 7. Now, periods are showing energy levels. Energy levels are going to be important to us for our trends that we're going to see on the periodic table, so how it's organized. And when you think of these energy levels, I want you to think of them as layers, okay? So as you have one energy level, you have one layer. As you have 2 energy levels, you're going to have 2 layers, and so on and so forth. And so think of it like that. If it helps you to think of the Bohr model with the rings that are on the outside that we put the little electrons on, that's fine. But just remember that you're thinking layers, and that's going to help.